and to make you familiar to my beginner's journey. And for that reason, I've made a short presentation. At home it was less than 30 minutes, so let's see how much time I have here. And I will talk about my inspiration, because if you start a journey, you have to put the first step. And the idea is, in what direction will that first step be, because that's crucial. And so that was my inspiration. I did some experiments at 23 centimeters, and then I went to 3 centimeters. And I'd like to present you some conclusions of the journey and some of my future activities. Where did I get my inspiration from? Well, to be honest, I'm very happy that Jan is here, because he was one of my inspirations back in the 70s. I was still a student. Jan was giving a talk on a meeting, probably half the size of this or something, and he was sitting on the table, very relaxed. I have a clear memory of this, because it made such an impression. And he was sitting on the table, and he was just as enthusiastic as yesterday. And he was sitting on the table, and he was talking, and then he said, "I'll now give a demonstration." And he pushed the button of a cassette player. At that time it was a cassette player, now he has MP3. And we heard a lot of noise and hiss, but the audience was silent, completely silent. You could hear a pin drop, as we say in Dutch. And all of a sudden, out of the noise, beep, 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 beep. And I said, "Is that via the moon?" And Jan said, "Yes, that's via the moon." And he demonstrated other things like the Sputnik and Apollo program, but I was literally electrified. So, and another inspiration was a little bit later, but it was by my late friend Marcel Fassler, who introduced me to microwaves. So I was working on 80 meters, I did something on 2 meters, 70 centimeters, but everything above 1 gigahertz, that was in fact too complicated, you know. But it was a dream. Earth was a dream. Because you need a huge antenna, 6-meter dish. Now, all of you know that Holland is a very dense populated country. And if you have a back garden, you are already lucky. But if you have a big back garden for a 6-meter dish, then you are, in my eyes, rich. So that was out of the question for me. And a ring of 2C39 tubes, wow. The mechanical effort, but also the high voltages involved. I have had some painful experiences with high voltages, so ever since I thought solid state only. Well, the space we talked about, CW, well, I passed my CW examination in '74, but I didn't practice a lot, so it's pretty much rusty. So it was difficult at that time, it still is. And well, as I said, microwaves are a challenge, so I kept dreaming and reading, and in the meantime I spent a lot of time and energy in building all equipment from 80 meters until 76 gigahertz. So microwaves in the end were a little bit less a problem. So early this decade, just around 8 to 10 years ago, in my reading efforts, I came across the stressed dish reflector of LK's. And I thought, wow, maybe that's a good idea to make a dish antenna. And he also convinced me that maybe an antenna of 2 to 3 meters is big enough. And he did it from wood, and I will show you a slightly different approach, but the idea is the same. And we have high performance low noise amplifiers. Thanks to G4DDK and WA2 ODO and others, DB6MT, very good amplifiers were possible. Solid state RF, that was for me, of course, very important, so even solid state RF became affordable. And don't forget the software of Joe Taylor, that was very instrumental in making QSOs, not only then, but even today, more than ever, I would say. And the work of Paul was also instrumental, because he developed or he published about efficient feeds. And it was so possible for small antennas to work with an efficient feed. And Zdeněk also did some crucial work, in my opinion, by making available the circular polarization feed many of us use. And finally, and not at least probably, the big gun, the 25-meter dish, in Dwingelo became active. And I thought, well, whatever happens, how bad my system will work, probably I can work Dwingelo. And then I started a little bit calculation with VK3 UM, and I thought, let's go for it. So, a small parabolic dish, and in my case, I preferred the dish over Yagi's because of the circular polarization. And I wanted a self-supporting reflector. That would be probably the way to go for me. And then I came to the idea that from the kite industry, they use fiberglass rods. And you can buy them in all kinds of diameters, hollow, solid, whatever. But I just picked one with an outer diameter of 8 millimeters and inner diameter of 6 millimeters. And you could buy them in lengths of about 120. And I thought, wait a minute, if I clamp one end and I pull with a rope, let's see what the shape will be under the force. And I made on cardboard a rough parabolic drawing, and I thought, well, close enough. So I start buying 18 of these rods, 12 for the spokes and 6 for the rim. And the crucial idea is that I use the rim to force the parabolic shape. So I didn't need ropes to pull the shape, but it is forced by the rim. And well, I had a solid camera tripod, so I thought that would be the idea. So the central of the dish is a kind of a star construction with 8 millimeter brass tubes, sold by the same kite company. And I made a sandwich construction, wood, the brass tubes, and an aluminum disc on top of it. And so it looks a little bit like this. And this is one of the first tests with the system. And then I added, of course, the mesh. I have mesh of 10 millimeter square holes. And I was aware that probably I could use the dish at 23 centimeters and at 13 centimeters. So that was my horizon. And crucial is, of course, these elements, also made by 8 millimeter tubes and hard soldered. Here you can see it. I made 12 of these joints, and well, finally this was enough to force the parabolic shape. I added chicken mesh, as I already told you. It's partly folded around the spoke, and the rest is just a bunch of tie wraps. Very simple, and I have to say that this structure is not meant to be placed outside permanently. The idea I had with my EME system, because at that time I had a small backyard, and I thought, well, I can do it here, but I have a moon window maybe of 2 hours, which is not enough. So basically the idea was to make it portable, or let me say transportable. So whenever I want to be active, and that's until today, I have to make the whole structure. Today I moved, so it's on the balcony, I will show you later. But then I have to build the antenna, which is about 3/4 or an hour work for 2 people. And then I can work EME. But as soon as it starts raining, or hard wind, or bad weather, I'm out. So that's a little bit a restriction I have. So the resulting dish is 2.40 meters with roughly 0.42 FD range. And in the beginning, and I still use it, I use the septum feed by Zdenjak, but without yoke. And this is how it looks like. This is also a picture of my backyard. And this is one of the first tests when we try to apply the mesh. And this is failure number one, so to say, because if you have just a reflector that doesn't weigh so much, then you can use this kind of trepo. And in fact, this is sturdy enough. This is not the problem, but you immediately understand that this is the problem, because this center hole is supposed to carry the feed. Well, that doesn't work at all. But it doesn't matter. We go on, and this is the actual structure, and that's already pretty much advanced. And the interesting thing is here that I made this much better. This is a door hinges, RVS. This is, of course, the elevating actuator. And the central pole has moved. Originally it was planned here. It has moved upwards because it was much easier to suspend the feet at the other end of the pole. And you can't see it here. And here, this is not where I normally attach my power amplifier. So the only counterweight I have is my power amplifier. And what you see here is the MAB25 elevation sensor in a box, mounted in a box. It's a 12-bit sensor. And here you have a kind of a pendulum of about 250 grams, and that is enough to measure the elevation. No, 12 bits, so 0.1 degree. I'm not claiming 0.1 degree accuracy, but 0.2 degree I would. So for this antenna, it's way too much. So how do we do the tracking? Well, at first I used a KR1000 rotator, but that gives too much play, so I was not very happy with it. The elevation you have seen, that's a satellite actuator. The controller was a OA5 JFL, and to be honest, later I replaced it with my own design because it was, well, I preferred a more modern user interface, let me put it that way. It works fantastic, both controllers, but yeah, I wanted a better user interface. I have a very old homebrew IF transceiver. As I said, I made equipment from 80 meters to 76 gigahertz, so this is a homebrew transceiver when I was a student, about 30 years old. And, well, you can imagine, no RIT, no cut control, well, that's already something. And I made later audio, I/O, and Vox, so at least I could use WSJT. And my DB6NT transverter for 23 centimeters was modified in the sense that I stabilized with an OCXO, and that works fantastic, no problem at all. The LNA works nicely, and for measuring sun noise, moon noise is out of range, but for measuring sun noise I use SpectraVue with the continuum mode. And how about some first RX results? Well, about 6 to 7 dB sun noise is easily obtainable. And in July 2014, I heard my first stations in CW, SM4 ITE and I1 NDP. And well, I was already very happy, as you can imagine. There was a lot of work, and there is still a lot of work to be done, but this was a real achievement. And it turned out that the dish was not rigid enough, not in the sense that the shape was okay, but the shape was wiggling, you know. So I added 4 ropes to support to the supporting feed structure, and it is not, I repeat, to force the parabolic shape, because that remains unaffected by the ropes, but just when you move the dish to keep everything in shape. And I was advised to use a yoke, and I thought, well, it's such a small dish, only 2.40 meters. If I add a yoke, what will happen? And, but it gives a 1 dB increase in sun noise. And then I started to optimize, because I hadn't done it before. I just took a lint meter and said, okay, according to theory, it should be 98 centimeters. So let's do that, and in practice it's different. I think most of you know that. So I drilled holes every 2 centimeters, and I just, on sun noise, no GT, complicated things, just sun noise, and I optimize it. Now, the optimum is quite wide because it's a sine function, but anyway, a couple of tenths of dBs gained. And in the meantime, I also changed QTH, and I'm now on the balcony. It doesn't help me much in moon window, maybe twice as big, but still not so big. But anyway, it's easier to build it up and to put down all the other equipment you need, so lots of computers and electronics and power supplies and all you know. And this is the guy who advised me to to use. This is Al Katz in teaching mode. So here we have the yoke, and it was quite funny because I was looking for the dimensions of the yoke, and I looked at all documentation I could find, but I could not find the source of my dimensions. But well, it's a 48 centimeter diameter. It sleeves over the OK1 DFC feed, and here you can see the low noise amplifier and relay and all those things you need up front. So how about the first transmitting results? At first I used a 150 watt RKE amplifier, and as I said, it was directly mounted behind the dish with a small piece of coax. Actually it is self-flex, but it used to be some EcoFlex 15 or something, but it's too lossy. And I measured the power, well, not exactly the power, but whether the whole construction works or not is very easy to detect, because if you start transmitting, always a small portion of the transmitted power goes back to the feed, but then it's reversed in polarity, so you will detect that on the receive port. And as I need a protection relay in any case, I just divert the receive power on the RX port during transmission to a detector, and then it goes all the way down to the transverter, and I can keep an eye on the power. It's very convenient, I think. Okay, so here we have Nando again. And I work Nando in CW, and I thank him for his patience, because my CW is far from perfect, but I was already very happy to work him and G4CCH with nice signals, so that was a good moment. So what is the actual situation on 23 centimeters? Well, actually I have a modified PST 2051 rotator, because as I said that the ordinary azimuth rotator had too much play, and this one has a warm gear, so that's much better to control your antenna in the azimuth direction. And there is a small pot meter under. I don't know, some of you will probably know that. I immediately removed it and inserted MAB25 sensor, which is very easy to do. You were surprised how easy it is. I made a write-up of that that is referred to later. And that gives me a perfect control in that direction. I also increased my power to 300 watts with a DF9 IC amplifier. And by the way, I'm very happy with this amplifier. I built a couple of them, and they seem very reliable to me and very affordable. Well, I said already that I replaced the transmitting cable for self-flex, and this year I worked a number of stations, many stations, and I now have 19 initials on 23. And I even heard HB9Q in SSB. Alas, I never ever was QRV when PA9CAM was there, which is a big shame because I know Muller very good, Professor Muller, because he was my teacher in microwaves at the University of Twente, and to his honor, I definitely would like to make one, but we will have that in the future. But in my opinion, the station gets, let's say, mature some way. This is how it looks like, and don't blame me for the picture, it's not so good, and I will tell you why. The balcony is so small that I need a fisheye lens to take a picture of my antenna, and I don't have a fisheye lens. So this is, but well, you have an idea of how it works. The feed with the yoke, there is no PA attached because I was receiving. Here is the transverter. It's under plastic because a little bit rain is okay, but or during the night or something. But it's basically a beautiful weather station.
5 minutes.
Oh my God. 5 minutes for 3 centimeters, that's impossible. Good. I have to go on. Yeah, at home it was only half an hour, but
That happens to all of us.
you're so inspiring. Okay, so we have to go to 3 centimeters quickly. I was this time inspired by HB9AFO with his PLL LNB stuff, and PA0HRK. Just as difficult to do in CW as to pronounce in English. And at the EME 2014 conference, and I thought that if he can do it with a small dish, I can do it as well. So I bought myself a 1 meter dish. I started with an Avenger that was not stable enough. I have to speed up a little bit. Then I immediately modified my DB6NT transverter. Just simple locking it with an OCXO of high quality is already enough. It really is. And I have a couple of LNAs available just for fun, and a surplus TV feed. And here you can see the old PLL system, and you can see the feed aperture is illuminated by the sun. Yes, because the antenna is smaller. So, the first RX results were about 8 dB sun noise. I heard OZ1 LPR, that was, well, you can hear it probably with the feed horn alone. And G3WDG in CW, the moon noise. And that was to me a very nice surprise that I could see moon noise actually, 0.3, 0.4 dB. DL0SHF was heard on speaker level, but Doppler is killing you at about can be 1 hertz per second. And I also found out that if I change LNA, I already have to adjust the elevation calibration. Now, on to the next step, the transmitter. That was a little bit of a problem because I told you high voltages are out. So it must be solid state and it must be a nice beefy power amplifier. So with the help of Charlie, unfortunately he couldn't be here, but he did a lot of help. And he provided me the PC board, and that was based on his article in Dupus. Many of you probably have seen it. And I used TGA 2623 and 22 watts output at 28 volt, gain of 30 dB, and that's crucial because then you can directly drive it by DB6NT transverter. That's fantastic. I imported the FET myself. At first there were all kinds of export restrictions from the US to Europe for these kind of devices. But if you fill in a form, very simple form, and all of a sudden, within a week, I had my device. So I was very happy. And now you want to know my first TX result. Oh no, first we can see a look here, but we don't have so much time. But this is the output, this is the input, and this all is maybe, well, maybe the distance here, you know how large an SMA connector is, maybe 2.5 centimeters or something, 25 millimeters. So what is my first TX result? A blown amplifier. Didn't you use a sequencer? Yes, sir. But the sequencer was based on SMA relay and not on a bulky waveguide relay. Okay, no problem. We changed that immediately. We have some low noise amplifiers in spare, so I just replaced them, and I could work OZ1 LPR and G3W DG in QRA 64D. And fortunately, they did all the Doppler correction. So, oof, otherwise it was not possible. And there was a small bug in my radio. 10 years ago, I changed my LO, and I forgot to exchange the LSB and USB wires. So they said, we see you, we hear you, we can't detect you. Yes, I said, the same for me. And then Charlie was so clever, he said, give me 1,000 hertz tone. Okay, give you 1,000. Ah, I know what your problem is, so very clever. This is my actual 3 centimeter front end. Here you see the LNA, the bulky relay, the commercial feed horn. I have a small waveguide to the power amplifier, and this is a very old DB6NT transverter modified, and this is to deter other birds. So the future, well, a much better IF transceiver. Actually, I'm waiting for the IC 9700. I hope that will solve much of my problems, not all of them. I want to hear my own echo in CW on 23 centimeters, so I already combined 2 DF9 IC amplifiers for 600 watts, and then it should be possible if you're clever enough to compensate for Doppler, etc. I want more power on 3 centimeters. I made also some other gallium nitride amplifiers, and I want to combine them to make 60 watts. And the following transverters are already available: 13 centimeter, 5 centimeters with a 1 meter dish, and 24 gig. Why not? So what you can see here is that the journey never ends. And I think all of you know that. It never ends. But it doesn't matter. It's fun. So that's what I say. It's fun. So go for it. So all of you know that, but it's also nice that this or these kinds of presentations go to a wider audience. Okay, okay. So make it rigid, but not heavy. It's semi-portable. Yeah, I go. Improve continuously. That's an important thing for me. Keep a log. I note everything what I do. I note everything what I change, but I also take notes of what I want to change. So a to-do list. And then mark out what you have done or not or whatever. And it is so easy to go back. What did I a year ago? I don't know. I don't remember, you know. But if you have a log, it's fantastic. It will help you absolutely. Be sure that the FunCube dongle works in the linear area. I'm not going to explain that at this point. Finding the cold spot is difficult because my place is so small, the balcony, that I have only 2 sides open and the rest is building and everything else that is 273 Kelvin. Improve operating practice, yes, that I have to do. Otherwise, I'm very much depending on what others can do for me, and that's nice, but it's not what you want, you know. And a big thank to Simon. I think it's definitely at the place right now, because not only for his critical remarks, I can have that, and sometimes I do accept, but his mechanical support is sometimes indispensable. And here are some references. And well, I think I'm out of time.
Thank you very much.
Thank you. Yeah, thank you.
And you said the journey never ends, but the presentation ends.
Yes, yes.
You made some very good points, and it's all on video, so everybody who wants to start can see what you went through, and it's a big inspiration. Many thanks.
Thank you very much. Thank you. Thank you too.